Welcome to another edition of Sparky Help. This time we're looking at a quick guide to understanding engineering notation, as we can see on the screen here. So if this has baffled you for years, or baffles you now, or you just want to get to know, then please keep watching. Let's have a look at how we try and interpret this information. So the easiest way to do this is let's have a look at a simple number line. So who thought you'd be looking at this now? So we have three numbers on the screen, all zeros, but the important part is what are they? They are units, tens and hundreds. This is not new. This is stuff you've known for years. So how do we go about looking at engineering notation? Well, we need to know where these numbers stand, and this is a nice easy one to start off with. Engineering notation looks in multiples of 3. We don't need to worry about the first three, but however the next three you will be familiar with. If you've looked at wages or what people earn, then this number would be it for you, or in terms of weight in kilograms. So this is kilo, and this is in multiples of 3. So when we look along, we have the next multiple of 3, and you're probably again familiar with these, but this is mega. Well, as you can see here, a capital M is the letter that we would use to denote mega. Always in multiples of 3, and we'll only go to this one here, which is giga, which is a capital G. What happens after the decimal point? Well, again, it's multiples of 3. So we look at the next set of 3, and this becomes milli, which is a lowercase m. So don't get confused with a capital M, because capital M and lowercase m are completely different. So this is milli. After that, again, in 3s, we have micro, which is this funny U with a tail. After that, in a multiple of 3 again, we have nano. And it does go beyond this, obviously, and it goes beyond in either direction. So nano, pico, femto, atto, and so on and so forth. And the other direction goes up to tera and beyond. But for most situations, the ones we have on screen will cover a large area of your knowledge. How do we put these in? Well, they are raising to a power. So we have a number multiplied to the power of 10 to the minus 3 for milli, because it's 3 zeros, times 10 to the minus 6 for micro, because we are 6 beyond the decimal point, and obviously to 9, and it would be multiples of 3, but minus meaning smaller than 1. When we go the other direction, obviously units, tens and hundreds, we don't worry about that because we can express those numbers as a number, and most people would understand what you're talking about. I say most every person would understand what we were talking about. To kilo, it would be a number expressed to the power of 3, because there are 3 zeros after it. Mega would be times 10 to the 6, and then giga would be times 10 to the 9. And again, multiples of 3 along the way. So let's have a look at trying to put into the number line how we can convert easily in your head and make sense of numbers that maybe you're familiar with. So let's have a look at milli. What typical things would we have for that? And if for this would be milli would be times 10 to the minus 3 for engineering notation. So look at 3 milliamps. So where would 3 milliamps be? Well, if we come back to the number line, 3 milliamps would be written down in that location. 3 is down that end, the first, as it were, of the block of 3. So when we put the 0 in, it's 0.003. Okay, which is a thousandth. So 3,000th of an amp. So this is quite small. 30 milliamp, where would that go in on the number line? Well, it moves along a space, so it becomes, putting the 0 in, becomes 0.03. Obviously, no point saying the 0 at the end. So 0.03 or 30 milliamps would be one and the same number. 300 milliamp, where does that go? Well, let's look at there, and it goes at that location there. So as you can see, we're moving along. So that becomes 0.3 of an amp. So they would be the same number. Let's look at some more examples. So let's look at for kilo, which is times 10 to the 3, remember. Now here we have a monetary figure of 3k. Everyone would probably know that that would be 3,000. Obviously, where it would go on the number line, the 3 goes in that location on the block of 3. Adding the zeros in, 3,000. Obviously, most people would recognise this. 30k, well, the 30 goes along to the middle one there on that particular number line. Adding the zeros in becomes 30,000. Because it's to the power of 3, it means 3 zeros at the end of it. Let's look at 300k, and these, I know these are quite simple, but it just helps you to understand. 300, adding zeros in, £300,000 in this case, or dollars or yen or anything else you wish it to be. Let's look at some more. So let's go the other way this time. We'll go 1.2 gigabytes now, probably something you've seen before. Giga is right up there, which is times 10 to the 9. Where does the 1.2 go? Well, it starts at the end of the beginning of that 3, and there's an imaginary decimal point in there, so it becomes 1, and then the 2 goes into the next one over, and then the zeros can go in. So that effectively comes 1.2 billion bytes, or 1.2 gigabytes. About this one then, 0.5 mega ohms. So mega goes in this location, which is times 10 to the 6. 0.5 goes in this location here. Adding the zeros in then becomes 500,000. So that's 500,000 ohms, or another word you could say for this is 500 kilo ohms. Let's look at this one here, back to the monetary value again, 32.5 K. So there's our K, kilo, that's times 10 to the 3, and 32.5 would go in there with this imaginary decimal point in this location, adding the zeros on, 32,500. So hopefully when you see it on a number line like this, it's quite easy to convert, and obviously the more practice you get of this, you can do these conversions in your head. But if you don't want to do them in your head, why do that if you've got a calculator? So when we try and put these numbers into your calculator, either I've got to convert them into your head and put them as 0.003, but then it's quite easy to miss a few zeros out. So if you can remember it's to the power of 369 or minus 369, then that's more accurate, and that way you won't miss any zeros out. An often misconception is what people will press is they press this button here. This is factorial, so what it will do, it will multiply the number by itself by the amount of times 5. It will multiply that number 5 times by itself. So that's not the one we want to use. The button we need to use is this one down here, times 10 to the x, which will raise a power. So let's look at 30 milliamp. How do we put that in as engineering notation? Remember, this is engineering notation, so we can put 3 and then 0. So there's your 30. And then we raise it to the power, and then something like that will display on your screen, times 10 to the unknown number at this moment in time. Remember, this is to the minus 3, so we press minus, and either of these minus buttons will work, and then we press 3. So you end up with 30 times 10 to the minus 3. Now, if you were doing a calculation, you can just carry on doing multiply, divide, or whatever it is you wish to do, and the calculator now knows that this is 30 milli. However, if you wanted to just display it as you wanted it, we could just press the equals and the calculator will display it possibly in this form. So it just says it's 0.03, which is what we've looked at earlier. But what happens if you do a calculation and what your calculator will default to is standard form, which is, in this case, we have 2 times 10 to the minus 4. What is that? Well, the difference between engineering notation is always raised to the power of a multiple of 3, whether it be minus or plus. And the number that you're raising it by, so 2 in this case, that in engineering notation can be any number. So it can be 300, 200, 1, but in this form, it can be no higher than 9. So it would go, if it got to 9, or if it was 1,200, it would be 1.2 raised to whatever power it happens to be, whereas in engineering we could just say the number. But that's okay. If your calculator defaults to this, we have a button on your calculator, and it's this one here, ENG, engineering. And if we press that button, what it will do is it will convert it to the nearest power of engineering in this case. So it's gone to the minus 6. So it's 200 times 10 to the minus 6. And if we go back to the number line, or if you look back and think back what the number line is, to the minus 6, that's micro. So whatever the unit of this is, it's 200 micro, whatever the unit is. This will work. If we press engineering again, it will go to the numbers will go up, and it will go to the 9, 12, and if you press Shift Engineering, it will go the opposite direction. Either of those you can go one way or the other, or back to a number that you recognise. So what can we look at? So 30 milliamp as an answer would be an answer that you could write down or display. It could also go into your calculator as 30 times 10 to the minus 3, and we'd put amps at the end of that if you was going to write it down. Remember, that is also the same as 0.03 amps, but in standard form it would be 3 times 10 to the minus 2. All of those numbers that you display on the right hand side there are all one and the same number. So I hope having a quick look at this has helped in understanding engineering notation for all your needs. Remember, always come back to the number line. It's quite simple and quite easy when you know how to place it, and I hope it helps. Thank you very much.